Hello everyone, welcome to my channel. Let's learn computer science. Hello everyone, welcome back to another video. In our previous video, we learned about fetch, decode, execute cycle. But have you ever wondered what happens if the CPU is busy executing a program and suddenly something important needs immediate attention? For example, you press a key on the keyboard, a printer runs out of paper, or a program tries to divide a number by zero. Should the CPU keep doing its current task and ignore these events? Well, the answer is no. The CPU needs a mechanism that allows it to temporarily stop what it is doing, deal with the urgent event, and then continue exactly from where it left off. And this mechanism is known as interrupt handling. So, in this video, we'll understand the purpose of interrupts, possible causes of interrupts, applications, interrupt service routine or ISR, when interrupts are detected during the fetch, decode, execute cycle, and finally, how interrupts are handled. So, let's get started. So, first of all, what is an interrupt? An interrupt is a signal generated by hardware or software that causes the CPU to temporarily suspend its current task and respond to that event requiring immediate attention. So it tells the CPU, please stop for a moment. I need your attention immediately. When an interrupt occurs, CPU temporarily suspends its current task, deals with the interrupt, and then resumes the original task. Why do we need interrupts? Imagine if the CPU had no interrupts. The CPU would have to continuously check every device again and again. For example, keyboard, do you need me? No. Printer, do you need me? No. Hard disk, do you need my attention? Right? So this constant checking wastes valuable processor time, and interrupts, they solve this problem. Instead of the CPU checking devices repeatedly, whether they need its attention or not, devices themselves, they notify the CPU whenever they require attention. As a result, interrupts allow CPU to respond to important events, make efficient use of the processor time, support multitasking, and manage input and output devices effectively. Let's talk about a real life example. Suppose you're downloading a file. Okay. At the same time, you are listening to the music, browsing the internet, and maybe typing a document also. It appears as if all these tasks are happening simultaneously. Interrupts help the CPU switch attention between these tasks whenever required, making multitasking possible. Now let's discuss possible causes of interrupts. Interrupts may be generated by either hardware or software. We'll discuss about some common causes that you must know for the exam point of view. First of all, timer interrupts. Timer interrupt is generated by a system clock at regular intervals. For example, the operating system uses timer interrupts to schedule tasks in a multitasking environment. Timer interrupts are also used to update the system clock. Then we have input output interrupts. These interrupts occur when an input or output device requires CPU attention. For example, printer is ready to receive more data. a hard disk has completed reading data, or a USB device has been connected. Instead of continuously checking these devices, the CPU waits until the device sends an interrupt signal and then gives the required attention, right? Then we have hardware fault interrupts. These interrupts occur whenever a hardware error takes place. For example, printer paper jam, a disk write failure, or any hardware malfunction. Such interrupts inform the CPU that immediate action is required. Then we also have user interaction interrupts. Whenever the user interacts with the CPU or with the computer, interrupts may be generated. For example, a key is pressed on the keyboard, mouse clicked, special key combination such as Control Alt Delete pressed, right? Then we also have software error interrupts, and we have so many past paper questions based on this particular type of interrupts. Sometimes a running program encounters a serious error. In such cases, software interrupts are generated. For example, division by zero, some missing executable file, invalid instruction. These examples are extremely important from examination perspective. Please remember. Now let's see where interrupts are actually used, their application areas. Interrupts are used whenever CPU must respond quickly to events. First application is multitasking. Interrupts, they allow multiple programs to appear to run at the same time. For example, you may download a file, listen to music, and edit a document at the same time, right? Second application is input processing. Whenever you press a key on the keyboard immediately sends an interrupt signal to the CPU. This ensures that user input is processed without any delays. Third application is output processing. Now, output devices can also generate interrupts. For example, a printer may send an interrupt indicating that it is ready to receive more data. Fourth application is real-time systems. Real-time systems require immediate responses. For example, traffic light control system, industrial monitoring system, or medical monitoring system. In these systems, delays could lead to serious consequences, so interrupts are essential, right? Now, an important term, ISR, interrupt service routine. What exactly it is? Let's have a look at the definition. An interrupt service routine, also known as interrupt handler, is a special program that is executed when an interrupt occurs. Each interrupt type has its own ISR. You can think of it as a small program specifically designed to deal with a particular interrupt. For example, keyboard interrupt has its own ISR, printer interrupt has its own ISR. The ISR performs several tasks, like it identifies the interrupt, it performs the required action, services the interrupt, clears the interrupt, returns control to the interrupted program. Let's understand this using a printer example. Suppose the printer has finished printing a page and now needs more data. Printer sends an interrupt signal. Printer ISR is then executed, and the ISR, it identifies the interrupt source, sends additional data to the printer, clears the interrupt, and returns control to the original program. That's how ISR takes care of interrupts. Now, this is very important examination point that when interrupts are detected during the fetch decode execute cycle. There are so many past paper questions based on just this particular point. Students, they often think that CPU stops immediately whenever interrupts occurs, but that's not correct. Interrupts are normally detected at the end of the current fetch decode execute cycle. After the current instruction has been completed, CPU does not normally stop in the middle of the execution of an instruction. Why? This ensures that current instruction is completed correctly, the program is left in a defined state, and execution can safely resume later. So that's why CPU does not normally stop in the middle of the execution of an instruction. Right? Now, to keep track of the interrupts, the CPU uses a special register called interrupt register. Each bit in this register may represent a different interrupt source. Suppose initially, your interrupt register, it has 000000000 value stored in it. This means no interrupts are waiting. Now imagine a hard disk write error occurs and your interrupt register changes its value to this. This changed bit acts as a flag indicating that an interrupt requires servicing. So at the end of the current fetch decode execute cycle, the CPU checks the interrupt register to determine whether any interrupts are waiting. In case there is a flag raised, interrupt would be handled. Now, how the interrupts are handled, that is also very, very interesting. Let's understand that. When an interrupt occurs, how they are handled in fetch, decode, and execute cycle. This is very, very important from exam point of view. Please listen very carefully. This is the sequence that takes place. First of all, an interrupt signal is generated. In case any interrupt occurs, an interrupt signal is generated by that hardware or software. Then the interrupt flag is set in the interrupt register. As we have just discussed that there is an interrupt register. Initially, its value is, let's say, all zeros. Whenever some interrupt signal is generated, its value is changed. So CPU completes the current fetch decode execute cycle. It will not stop in between. If one instruction is getting fetched, it will be decoded, it will be executed, and then interrupts will be checked. So CPU checks the interrupt register. It identifies the interrupt type and its priority. The contents of the program counter and other CPU registers are stored safely. And this process is known as saving the processor state. The starting address of the appropriate ISR is loaded onto the program counter. The interrupt service routine executes. If further interrupts are waiting, they are checked and serviced. When no further interrupts remain, saved register contents are restored. The interrupted program resumes execution from the point at which it was interrupted. So that's the complete cycle. Interrupts are not handled during the fetch, decode, execute cycle. Rather, once one instruction completes its fetch, decode, execute cycle, at that point of time, interrupts are checked. If there are any interrupts, then interrupts enabled and interrupt priority checked, suspend execution of current program or task, execute interrupt service routine, and then go back to the next instruction. And the cycle continues. Okay, now let's have a look at some past paper questions. First question is, interrupts can be caused by software or hardware devices. State one cause of a software interrupt. We have just learned about this. Think about your answer. Of course, I'm going to show you the marking scheme. Then you can match. And it is of 1 mark. You just need 1 point. I hope you have got your answer. I'm just showing you marking scheme. So if you have written any one of these, division by 0, runtime error, out of memory bounds, program requesting an external device, input, buffer overflow. All these are examples of software interrupts. I hope this was the first option came to your mind also, because we have just covered this up in this video. Next question is, the following statements describe the stages that the CPU performs when an interrupt is detected. There are 3 missing statements. Write the letter of the missing statements. So these are the stages, and there are few missing stages. So you need to pick which one, in what sequence you have to write these. Okay. So just have a read, figure out your answer. So this is the marking scheme D, A, and B. So if I go up here, D, here A, and here it is B. So D, then A, and then B. Hope you got the right answer. There is one more question. Describe the purpose of an interrupt in a computer system and then identify 2 causes of the software interrupts. This also we have covered today, and this we have just solved this question. So purpose of the interrupt is to send a signal from a device or process seeking attention of the processor. And this, so you have just written division by 0, runtime error, attempt to access an invalid memory location, array index out of bounds, stack overflow. You may write these examples as well, right? One last question. State when interrupts are detected during fetch, decode, execute cycle. I told you this is very, very important. So interrupts are handled only after completion of the execute stage or before the next cycle begins, not during the fetch, decode, execute cycle, right? So after completion of the execute stage. So that's all for today. We have covered purpose of interrupts, including their applications, ISR, and how interrupts are handled. In next video, we'll learn about assembly code and machine code. Till then, take care and bye-bye.